Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Transforming for Agility and Growth with Smarter Connectivity and Integration. Our guest speaker today is Ms. Sargam Singh, Product Line Manager, ISA, WebSphere Connectivity and Integration at IBM. Sargam is the Product Line Manager for WebSphere Connectivity and Integration products, which includes Message Queue, Message Broker, DataPower, Cast Iron, and Service Registry and Repository offerings from IBM. She has an overall experience of 15 years and has been with IBM for past 8 years. She has been associated with WebSphere brand in different roles and has worked on several products including WebSphere Application Server, WebSphere Enterprise Service Bus, and WebSphere Service Registry and Repository. Prior to her current role, she has led development teams as well as test teams and delivered some key product features releases from India Software Labs. She also leads the Asia Pacific Tech Sales Support for WSRR and has been instrumental in extending support to several customers in this region. Sargam is an IBM certified SOA associate and possesses an in-depth understanding of the middleware technologies. She is a keen evangelist of technology and innovation that IBM brings to make the world smarter. So without further delay, I introduce you all to our guest speaker. Over to you, Sargam.
Thank you. So, can you make me the presenter? Sorry, I don't, I'm not sure if you can see my screen because I haven't moved to presentation mode. I don't see the control.
No, we cannot see your screen yet. Have you shared it?
I'm doing it again. I did that. Yeah, can you see it now?
No, it has not yet appeared.
Well, let me know when you see it. It says I'm showing it. Sorry for the technical issue.
Just making you the presenter once again.
Okay.
Okay, now we can see your slide.
Okay, great. So sorry for the delay of few minutes because of the technical glitch here. Good afternoon, everyone. And what we will try to do today in the next 1 hour is take you through the offerings from IBM in the space of connectivity and integration and take you through how you could just tie everything together to build up a holistic connectivity solution. There are 4 parts of the talk today. In the first part, we will look at what does it mean to be an interconnected enterprise. So what we call a smarter organization
Sargam,
is an organization which can freely...
Sargam, just a second. It's stuck on the title screen only.
Okay, I'm just going to the agenda. I'll go a little slow. I think it's taking some time to refresh. That's what it looks like.
See slide 2. You can continue. Yeah.
Yeah, I'll just try to, set a context and move the slide a little in advance. Looks like there is a delay in the refresh.
Yeah, sure.
Okay, just ping me if it's not visible.
Okay, sure.
Okay, so there are going to be 4 parts to the discussion today. We will look at what is an interconnected enterprise, which will set a context to our discussion. And then to be an interconnected enterprise or a smarter organization, what are the steps or what are the infrastructural backbone that you need to have in place for being able to use the data that your enterprise generates in a smarter way. So the second part will deal with the universal messaging, what we call. So how do you establish a backbone through which your connectivity can freely flow? How can you make your business agile is what we will look at as a part third. And then lastly, how could we extend the connectivity and integration layer that we have built to encompass the newer trends in terms of mobile, cloud, social, big data? So how do you use the enterprise that you have in place and leverage it to open up these newer channels? So I'm on the next chart now, chart 3. Hopefully it has refreshed by now. This kind of tells us what are the challenges of the business today. Okay, so there was a time when enterprises were more concerned with the data they generated and it was being more utilized for the internal transactions. But the business scenario has changed with the explosion in the number of data points that we have today. So this kind of sets a context into what an enterprise is facing today. So we have a lot new channels which have opened up to an enterprise. The enterprise is extending beyond their physical boundaries or even beyond their own branches, across to mobiles, to APIs, to devices, to sensors. And to be able to leverage all that, the connectivity requirement that is exerting on the enterprise are very different from anything that has been seen in the past. Then there is a need for these connections to be, maintaining a basic level of security, to be able to be sure that when you're passing your data and you're opening up newer channels, the security of your enterprise is not being compromised. So it could be data that you are sharing with your customers over mobile, or it could be an API that your partners are calling to call into your system. There's a basic need of security that kind of underruns all the transactions which happen. Then besides that, another thing which we have to be careful about is the ability to manage transactions, because most often the task that gets initiated does not complete at one point. So for instance, if a inter-branch transfer has to happen in a bank, the parties involved in making that transaction successful are going to be two different set of entities. How to make sure that the transaction that is happening across these entities is viewed as a unit. All these different ecosystem drivers are forcing us to relook at the connectivity solutions that we have in place today. Connectivity is also the base for being able to do the analytics on the data that you generate. And today the need of the day is not just analytics, but to be able to take an action and drive insights that you derive from your analytics into concrete actions. So that level of automation and that level of expertise which is getting generated needs to be utilized in a way which can be beneficial for the organization. Now, I'm on next chart and hopefully you see it now. So the kind of challenges that we are seeing with this change in the basic ecosystem are very different from anything that has been witnessed in the past. What has happened with most of the the companies or the customers or the enterprises that we work with, the different systems which interact today have evolved over a period of time. And what that has resulted into is a fragile point-to-point kind of connection. So in other words, customers have applications which talk to each other, and these connections are made on a per need basis. So if you have a, say for instance, you want an automation with your supplier where you want that as soon as the stock of an item is decreasing, you should be able to automatically intimate your supplier about the reorder. Now you look at that one instance in isolation, and you land up setting a point-to-point connection with your partner or with your supplier. Now a newer need comes where you feel that your customers need to be able to see the status of the order that they have placed with you online or on mobile, for instance. And when you realize this need, you again go ahead and you establish a connection between your customers and your enterprise application. So what starts happening over a period of time is that this mesh of connection starts becoming unmanageable. There is a lot of duplication which results because you land looking at each instance in isolation, and integration at enterprise level, the whole strategy of integration, the strategy of connectivity is often overlooked. It just grows, it evolves, and what you end up with is a mesh of services talking to each other, a lot of redundancy, which becomes extremely difficult to manage, very, very rigid in terms of if you want to make a small change somewhere, you need to bother about all the other parties which are going to rely on that particular service. This is a situation which we find customers eventually getting into when connectivity grows over a period of time, and they gradually find that the systems are becoming unmanageable for them. Or in other words, they're spending a lot of their time in maintaining the basic connections, making a change into the existing scenario takes a lot of time for them, and it's a very costly affair. So this kind of situation, when you have a lot of applications which are talking to each other, is typically a case where connectivity is there, but the architecture or the design patterns around connectivity are not in place. What this in turn leads to is that the systems that we now have are unable to meet the demand of the business. We start having something we call information blind spots, where you have information which is at some state in one system, and it is not synchronized across systems in a timely manner. You start going into batch cycles, and the updates which are reflected, there is a delay in the state of the particular transaction in one system versus the other system. So all this leads to missed opportunities, because at any point in time, you are not able to get the exact status of what is happening with the business. Over time, the integration challenges increase, and with the whole explosion in the newer endpoints, like you need to go over to mobile, or you need to start leveraging cloud. You want to get data from smart sensors. All that compounds the challenges which you are already facing, and you start realizing that it's becoming more and more difficult for you to introduce these newer opportunities. The reflexes that the business has to be able to sense and respond to stimuli, they become slower, and you lose the whole insight into what's going on, because it's difficult for you to analyze what's going under the covers. And lastly, there is a lack of agility. So agility basically refers to your ability to be able to quickly respond to a change in your business requirements. And that can happen when your infrastructure supports you. So with all this, what starts happening is business starts getting driven by IT, or rather constrained by IT. Whereas IT instead of being an enabler for the business becomes a hurdle, because you cannot, if you want to introduce a newer discount scheme, for instance, you need your systems to change, and that change is going to take some time. So you cannot do things which are driven by business. You need to see if your IT infrastructure back there is in a state to quickly adopt those changes and support it. So this is the challenge, which we eventually land into if connectivity is not viewed. But I see a message which says there's some problem with the audio connection. Am I still audible?
Audible.
Can someone please confirm if you can hear me?
Sargam, you're audible.
Okay. Okay, so the next chart that we have, I'm on chart 6 now. This is the the integration or connectivity landscape and how it evolves over time. So whatever I just talked about, you see an organization represented here, which initially talks amongst itself. You have a local environment in a firewall, and then there comes a DMZ, because the moment you start exposing the services and your data to the external entities, you put a firewall in place, so that only the authorized people can get access to your systems. Then comes the newer challenges of integrating newer channels, like you have cloud coming into picture, you have mobile, cellular networks, and rather than not just mobile, it could be data coming from absolutely any source. It could be some sensors put somewhere which you need to get the data from. You need to interact with your trading partner community. So this picture kind of consolidates the comprehensive connectivity and integration landscape that we see today for an enterprise. And what we are going to go through now on will tell you how we at IBM recommend the approach to addressing these challenges. What are the steps that we recommend for you to go across in your connectivity and integration journey, and which are the products that we have to support the transition. So with that, we come to the second part of the presentation, which is going to deal with the actual technologies behind the challenges that we just spoke about. The first one being, let's see how, because when we talk connectivity, the basic requirement is for some data to flow from one endpoint to another endpoint. And to do that, you need some mechanism, and messaging is one of the various ways in which we can do that. Most common one that we see is HTTP, but then messaging is a little different. And let's first start by understanding what do we mean by messaging. So when we say messaging, there are two ways. When an application A communicates to application B, the conversation between these two applications can be synchronous or asynchronous. So when we say synchronous, we are essentially saying that application A needs to communicate. It needs a response. Application A is going to send a request to B, wait for the response to come back, and then proceed with its work. So something like what happens when you use a HTTP kind of a transaction. You send a request, it gets processed on the server, and you get a response. So what's happening there is the sender application, the one which initiates the conversation, is waiting for the other application to reply, and only then it proceeds with the work. Whereas what we are, in case of messaging, what happens, the nature of communication that happens here is asynchronous. And what that means is, there is something called like a buffer in between. So application A sends a message which goes to this buffer. Application A can continue with its work. Whenever application B is available, it might be immediately or it might be after some time. That message is passed on to B. After the work is done, B sends the reply back, and then that comes to A. So asynchronous kind of transactions, what they mean is that one application is not essentially waiting for the task to be completed by the next application. It's doing its own work, and it gets to know whenever that work is done. Now, when we say messaging, there can be two modes or two types of messaging, and there are different protocols which are being used. But yes, JMS, Java Messaging Services, is what is the base. So when we are doing messaging kind of a request-response transaction, it could be a point-to-point scenario, or it could be a publish-subscribe scenario. So when we say point-to-point, we mean there are two applications in context here. Application A sends a request for B to do something. Once B has done that work, a response is received. Now what happens in a publish-subscribe model is there is a topic of interest to which different applications can subscribe. That this is the data that they would want to get. And whenever there is some data available, the owner or the publisher of that data puts the data on that topic, and the subscribers get the information. So if we translate this into business scenarios, maybe if you are having a fund transfer from one account in your bank to some other account in some other person's account, or your own account in a different bank, that is a point-to-point kind of a transaction, because the sender and the receiver are unique here. Whereas if it's an application which has to display a stock quote, for example, so to display a stock quote, it is listening to a particular topic. Whenever there is a data which arrives at that topic, they get notified and publish a newer quote. So I'm on the next chart now, chart number 10. Now when we say messaging, what essentially are we talking of? I mean, what is the challenge here? We have a protocol which lets us do this exactly what we are talking about. So what exactly is the challenge? The challenge becomes tough, because as long as all the systems which you are communicating with, or which are communicating with each other, are within your control, you know exactly what operating systems they are. You know what is the configuration, what is the hardware, what is the software. You are the decision maker there, and you can control that environment. But as we just saw, the enterprise today is exploring beyond its own boundaries and reaching out to other areas where it never thought of, where it was never envisaged that is going to happen. So what that does is it imposes a different set of requirements on your infrastructure. You need to move data between different systems, which could be having different platforms, which means different hardware, different software configuration, different programming models. Then when you are moving this data from receiver to the sender, or sender to the receiver, you need to take care of a number of things. you need to see if there are network failures while transferring the data. You need to make sure that when the information is being delivered, and in case the target application is not online, whenever it comes online, the message is delivered at that point. So assured delivery is there. You need to take care of that. You need to take care of the integrity and the recovery. In case when the message is being sent, the sender or the receiver gets disrupted, what happens in that case? So the applications could be as mission critical as doing the transfer of funds. You would not want to be in a situation where a transfer has been initiated from account 1 and it doesn't get into the recipient's account, or it gets reflected there twice. So you need to take care of the integrity and the reliability of the data transfer which is happening. You need to make sure that the data which is getting transferred is secure. There is no sniffing which is possible. It is encoded, encrypted, not only when it is transferred, but also when it is being held. So if the data is there in a queue, at that point, no other application should be able to sniff and to read the contents of that data. So these are some non-functional requirements which your infrastructure has to take care of. And mostly you'll need a way to impose these requirements. And how you do that could be either by programming everything in your application. You write code to make sure all this happens, or if you want a little more structured way and you realize that this is some code which is being reused time and again, you might land up with your own middle layer where you have this set of code that you develop, which each application can invoke and get this quality of service. But if you're doing that, you are spending your significant time and energy as well as significant cost in doing something which we call middleware kind of a work. So you are not just concentrating on your business, but you are also taking care of developing the infrastructure which is going to support your business use cases. That is where a company like IBM would come in, and products that we provide under our connectivity portfolio are going to do that for you. So all these, whatever we talked about, the things like different platforms, different hardware communication being connected to each other, network failure is being taken care of, integrity, recovery, security, all of these different things which I mentioned are going to be taken care of for you by the products which we are going to look at now. I'm on chart number 11, and it will take a couple of seconds to refresh. Meanwhile, so the first product which we will look at here is going to be WebSphere message queue. And what that does is, it just whatever we discussed in the last chart, the kind of reliability, scalability, security, transaction support, whatever we need from infrastructure which is going to let you transfer messages from point A to point B, all that is provided by this product. So WebSphere message queue, the whole vision that we have for MQ is to get the right data to the right place, right when needed, with the required quality of service. Now, when you start using this product, it's a very simple product. It just has a couple of APIs. So the application which needs to send the data has to use those APIs to put the data in the queue, and the receiving application has to use the get or the read APIs to get the data from the queue. And that's all that your application has to worry about. Rest, everything is going to be managed by this product. Once you have put a message into message queue, the responsibility of delivering it where it has to be delivered is of the software, in terms of making sure the message is encrypted. If the sender is not online, making sure there are retries, enough retries to make sure that the message actually reaches the destination it was intended for. There is a console which lets you see the messages which are flowing across the connectivity layer and see what is, how many messages are still waiting to be delivered. What is the status of your different queues that you have? So it's an offering which lets you do all of that, what we talked about. Now the beauty of this product is that a developer of any skill could use this. You don't need to be knowing a particular language to be able to interact with it. So I'm on chart number 11. If it has displayed by now, you will see that. So you could be having absolutely any skill. You can use any of the languages that you can think of to interact with it. The orientation of your code could be like, it could be a batch program, it could be files, it could be messages, services which you are going to transact through it. You could be passing a WSDL, an XML, REST message, whatever format the data is in. And the endpoints that it can talk to are just like, it supports like close to 80 platforms, and the platform is a combination of hardware and operating system. So, and we are adding more and more with every release. So message queue is like a 15-year-old product, more than 15 years actually. 15 years it has been a market leader, and there has been a continuous growth of devices, platforms which we can access through message queue. So if you want to, I mean, not just platforms, but say suppose you want to read the data from a sensor, you could do that through MQ. You want to connect from a mobile, you could do that through MQ. Of course, HTTP lets you do that as well, but MQ is another way we could do that. There's a whole set of quality of service which we spoke about: transactionality, persistence, then message delivery, guaranteed message delivery, low latency. All that is taken care here, and it supports different kind of deployments. Like you could have a point-to-point kind of a scenario, or a publish subscribe, unicast or a multicast. You could be talking to an appliance or cloud, or any of those different environments which are accessible. So what we kind of tell here is, using message queue, an enterprise should look at creating a messaging backbone. And when we say backbone, we are essentially saying the points which have to talk to each other should be connected on WebSphere message queue. What that does is it rids you of the responsibility of writing the code to take care of connectivity. That level of service is guaranteed. The moment you have message queue in your environment, you get that out of the box. You don't spend time, effort coding that, maintaining that, and there is the industry expertise which is at your disposal, because this product is being used by thousands of our customers very successfully. So the chart number 12 shows you the different quality of service which message queue guarantees, and as you can see in the graphic there, we have different kind of endpoints we could connect to, like sensors, mobile services, files, applications, and many others. So to simplify things a little, then just if you need a one-liner on MQ can be thought of as a mail service or a email service for SOA application. So when one SOA application needs to communicate to another SOA application, this could be the channel which you use to do that. So I'm on chart number 13 now. As I said, that we could connect to nearly everything. It's like IBM is looking at evolving message queue as a universal messaging backbone, and we see new endpoints being added to it. Now, the base message queue, the basic simple message queue is, to enable this basic messaging feature which I talked about. But we are adding newer features to it, and chart number 13 shows you the different kind of features which are available. Like we have a file transfer capability. What that lets you do is, we have a lot of businesses which are transferring data using file transfer protocol, FTP. Like for instance, if you have to order some items with your supplier, you could be sending an Excel sheet at the end of the day or end of the week or whatever is the process, which contains the list of items and the order quantity. We have a lot of cases where banks have corporate customers, and they sell, like corporate customers could be like these companies who all their employees have the accounts there, and at the end of the month, the companies or the corporate customers send a list of debits or the salary transfers which have to happen to the employee account. So all this is happening in form of files, and if you are using FTP to transfer these files, there is absolutely no visibility. You don't know how much of it has been transferred, what has failed, how much of it is duplicated. So if file transfer is what you are doing, MQ has a capability which lets you do that, and even monitor the complete movement of files in your whole infrastructure. Then we have messaging security, which is an add-on feature which lets you protect messages not only while they are moving through MQ, because that is there in any case. Any data that moves through MQ is encrypted. It also lets you, if you add this feature on, it also lets you protect the messages when they are at rest, when they are just sitting on the queue. And then, if you want to talk to the devices, the sensors, we have MQ Telemetry. There is MQ HTTP bridge, which lets you connect to the web application. Excuse me. And there is low latency messaging for applications which need near real-time data. So the latency, especially on it kind of works at the network layer, InfiniBand and Ethernet, and provides you extremely fast messaging. And MQ is also available as there's a hypervisor edition which is available, which lets you host it virtually as well. So this universal messaging backbone product that we are talking about lets you do all this as a single product. I mean, all these capabilities are available as a single installable. And of course, if you don't want to go for everything, you can slice and dice it as well. You can just choose to, have the part which you need, or you could go up for a complete full-fledged messaging offering. So I'm on chart number 14, which is kind of a summary on MQ, what we saw. Message queue gives you a robust, scalable messaging infrastructure. There's a base messaging which is available, and on top of that, there are these 4 features which we just looked into: the file transfer, security, low latency messaging, and telemetry. Now, now that you have a messaging backbone in place, you have laid down the endpoints, how they are going to talk to each other. What is the next step? The next step is going to be to enhance this connectivity using an enterprise service bus. So when we say, it just logically builds on top of whatever we have discussed. So before we really move to a product here, let's just understand what is an enterprise service bus. So back when we started talking about service-oriented architecture, the whole model or the design that has evolved over time, and the reference model which we had at that point as well, talks about these loosely coupled services which act as a building block for an application. So service-oriented architecture is just the base for whatever we are talking. I mean, in other words, if today you are looking at opening up a channel, your current requirement is that you want to open up the mobile channel, you really need that base there to be able to leverage the newer channel. Because if your systems are tightly coupled to each other, if you are not granular enough, you will end up rewriting your whole business logic for every new channel that you open. So essentially, we are assuming that the company is there at the SOA level. And if you are following service-oriented architecture, the heart of your interconnected enterprise is the enterprise service bus. So enterprise service bus is the integration layer or the connectivity layer which connects these services together. And it's essentially an architectural pattern. And we do have a product which fits that space, but the companies which are not using a product today would still be having I'm assuming would still be doing an ESB kind of a pattern where all their connectivity logic is in a separate layer, which the different applications can reuse. So again, we come to the same point. You have an option of building it, maintaining it yourself, or going for an offering which is available in the market. And again, being a middleware application provider, here is an offering that we have, which is Message Broker, which lets you establish, maintain, and develop this integration code or the service enterprise service bus kind of a functionality it provides. So when we talk of an ESB, ESB, now you already have a messaging infrastructure which guarantees you that the data is going to reach the recipient. Now, where does the ESB fit in? What is different that an ESB is going to do now? Now, what enterprise service bus does is much more than just, because infrastructure level transfer of message that is already taken care of. Now, what is needed beyond that is there could be some condition based on which this message has to be routed to a different application. So, what we call content-based routing. So, it could be a condition like if the customer who has sent the request is a gold customer, then service A has to be called, and if he is not, he's an ordinary customer, then service B has to be called. So to do this routing, essentially what you need to do is you need to read into the message, go into the contents, and then take a decision. A messaging infrastructure will not do it. MQ will not do it. MQ will not touch the message. All that MQ has done so far is it guarantees you that the message will reach its destination. It is not going to worry about reading the message. This is something which an ESB will do. It will do content-based routing for you. It will do conversions for you. So if the sender of the message has sent some data as XML, but the recipient wants the data as a comma-separated format, that conversion of data formats can be done at ESB. So these kind of use cases is what an ESB handles. So I'm on the next chart, chart number 17, which kind of touches upon how your applications would look like if you do not have an ESB. You will have systems talking to each other and doing it. Probably it'll always be different protocols. You cannot guarantee protocols because you are going to eventually land up talking to applications which are outside your ecosystem. So if you have to place an order with your supplier and the supplier exposes a web service, then you will end up making a web service call. If the supplier says, you give me the message as a JMS message, then you will end up doing a JMS call. So without an ESB, the applications start having a point-to-point connection. They start talking to each other. The first initial thought that we started this talk with. And the moment you bring in an enterprise service bus, what it does is it creates a very clear connectivity layer where you could develop the code of integration which can be reused. So, you could have, this is exactly what this product which I'm going to tell you about is going to do. You could have a conversion logic of converting XML into comma separated format. Any application that needs to do this conversion gets to use the same logic, and that code is maintained written only once. Now, when you are building this, because it's eventually coding, you need to look at the sender's format protocols and map it to the recipient. And it can be a little more complicated than that. Like, when we talk of integration, a very, very, obvious use case is something like you may have a case where a message comes in which needs to be sent to 2-3 recipients. Their responses need to be aggregated and a final result given out. Like, for instance, when we make these travel reservations on the sites, you get option to book your flight, book your hotel, book your taxi. What that is doing, that application is doing, is essentially there are 3 flows which go out. There is one request which comes in for a reservation. There is a taxi application which is hit to know the availability of taxi, know the availability of hotel, know the availability of flight. And definitely the person who is hosting the site is not going to be the person who hosts or who owns these 3 entities. So he will be making external calls. The integration layer will let you develop this kind of logic where you could branch out, fan out, get some details, aggregate it, and send it again back to the end user. So this is a little complicated integration scenario. So all these kind of facilities are provided by a product that we have, which is called Message Broker. Now, as I said, you need to have a robust infrastructure to transfer message in the first place. After that, you build this. This is a functionality on top of that. So if you are going for a Message Broker product, Message Queue comes automatically. When you don't have to buy these 2 products. If you buy Message Broker, Message Queue is there. Message Broker kind of builds on top of Message Queue, to put it in other words. So what Message Broker lets you do, I'm on chart number 19 now. Hopefully you see it now. It lets you perform these, the basic requirements plus some advanced things from the perspective of an ESB. Message Broker is more like a tool, I would say. You don't have to. There's very little in terms of coding that you have to do. You can. When you install Broker, you get there's a runtime which is there where this integration is going to run. There is a toolkit which comes. You just drag and drop and make connections. There is some bit of code that is often needed, and we do have those places where you could put that code. But more or less, the whole integration can be designed in few simple clicks. And I'll give you examples and what kind of integrations can be those. So what Message Broker will do for you is it will do the routing from an incoming request comes from a service consumer. It will route that to the correct service provider. It will convert the data formats, the protocols. So the transformation and the conversion is handled by it. So if you are if the provider of the service is expecting an XML to come, but the consumer has sent the message in the form of a comma delimited value, this transformation from CSV to XML will be taken care by Message Broker. It will, distribute some events, business events, like business events could be something as simple as the provider is down, or something more complex than that. It lets you integrate not just different protocol and different kind of formats. It lets you integrate different environments altogether. So you could be integrating devices using Message Broker. You could be having some .NET code that you want to talk to, use the .NET Core and talk to maybe some Kix mainframe application, or use JMS and talk to SAP. All these kind of integrations are possible using Message Broker. So Message Broker lets you rapidly build these integrations through a drag and drop kind of an approach with minimal coding. And one of the more interesting things which you could do here is you could very easily integrate with packaged applications. When I say packaged application, you have a SAP system which you are using, any of the modules of SAP that you are using, or Siebel, Oracle, Microsoft Dynamics, PeopleSoft, any of these CRM, ERP kind of application that you are using. If you want to integrate these with any of your other applications, it can be very easily done using Broker. So Broker has inbuilt nodes, what we call. What you have to do is there's a toolkit which opens up. You have to drag and drop. Suppose the incoming call is from a web service, and it has to go out, talk to SAP, then do some transformation and give the result as GMS. That whole, we call it a flow. You could construct that flow by connecting nodes and arrows, and very little coding as needed, by a particular use case. But that's what chart 22 shows you briefly. There is a flow which we have tried to show there, which is a .NET flow. The input is coming from a file, and then it's doing a Microsoft Dynamics lookup, changing to Excel, calling a COM DLL, and logging a of the flow. So these kind of flows is what we create. If you can see chart number 22, that is what the toolkit looks like. So Message Broker as a product is extremely easy to use. It is available in different flavors, so you don't have to go with a full install offering in the beginning. There is something called Message Broker Express, which we kind of introduced last year for our smaller customers who do not have a full-fledged requirement but who need a fairly simple integration kind of a environment. So in case of Express Edition, if you ask me, it takes like 15 minutes to install. Extremely small download, it's like a 70 MB kind of a footprint that it has. So simple product to use. It's very easy to learn because all these integrations that I'm telling you are available as patterns. So there is a tab. If you see the screenshot which I have, there is the second picture that is there, shows you the pattern explorer. And the pattern which I have highlighted is a healthcare pattern there. There are many such patterns which are available. So if you select a pattern, it will give you a suggested flow. You can change that flow. You normally have to modify it. Like at times you can use it as it is, but mostly you will need some bit of customization at least. So very easy to follow, and a lot of examples are there. And as I told you, it's all visual designing, so it's easy to develop. To deploy it, you don't need to come out of Broker, start a server separately and things like that. There is a development, testing, debug environment all inbuilt here. All you have to do is drag your flow, drop it onto the runtime, and you can go test it. Test client is extremely sophisticated if you need to give, because a flow is something which is going to come between consumer and provider. To test it itself, you need the consumer, you need the provider, and which is like you need all those applications in place before you develop the integration. So what the test client does is it can simulate the consumer and the provider flows. So it can give you some test data, generate the test data for you, pick up from files, and let you test your integration pretty much in isolation without really going for a big bang infrastructure to be there. And then it has something called a Message Explorer, which gives you a management view where you could see what's going on, monitor the different queues, the messages which are in your system, and go and manage it. So that is the second product which I wanted to talk about. Now the third or the last part of the presentation talks about once you have a messaging backbone in place, you have an ESB in place, Enterprise Service Bus, which is Message Broker, to take care of building your integration code. So you're all set to easily extend the reach of your enterprise and embrace the newer channels that we spoke about in the beginning. So, I mean, when I say new channels, I'm essentially referring to 4 things here. One is mobile, which is we are seeing a huge explosion, a lot of interest on mobile at this point. So if you have an enterprise which has an ESB in place, it's very simple to get onto the mobile channel. Similarly, cloud. or big data. Big data is trying to get data from so many other sources, which was not that possible before this, and doing the analytics on top of that, and social. And then let's look at these one by one. I am on chart 24. Hopefully it shows by now, which shows you the evolution of the enterprise systems. So back in 1960s, the era was the mainframe cakes kind of an era. The systems which were thought to be cutting edge were transaction-oriented systems. Distributed transaction has started coming up. And then and if you see this chart that I have there, it's not that gave way to the next wave. No. On top of that wave, we saw service-oriented architecture wave. So when SOA happened, the previous wave was the reason which gave birth to SOA. We started seeing the need for granular, self-contained services which could act as building blocks for a larger application. And I mean, I see the picture is very small there, but the backbone of SOA is an enterprise service bus. So you have a connectivity layer, an enterprise service bus, which is the logic which is going to make these services talk to each other. And then now what we are seeing is the new era, or the next big wave, which is the wave of social, mobile, cloud, and big data. Now let's see, how are you going to expand the connectivity that you have in place and embrace these 4 new challenges? How would you take care of mobile, of cloud, big data, and social? So let's get started with cloud. So I'm on chart number 25. It'll take a while to come up, I guess. So when we talk of cloud, you have some systems within your enterprise, which is what we call on-premise. So on-premise systems are the ones which you already have. There could be different ways of going on to cloud. One, mostly what we are seeing is where you go and you or your customers who you are working with go, and they want a service on the cloud to be integrated with their on-premise system. Like for instance, a company has all its systems working on like on-premise. They want to go for CRM. They do not want to buy a CRM. They go and they take the CRM from Salesforce. So what you will need to do is CRM functionality is going to come to you from the cloud, but that CRM needs data from your systems inside your enterprise. That is where integration comes. So Salesforce, of course, gives you the facility in terms of the CRM that they are providing, but the data which is going to drive that is back on your premise. So that the integration between cloud system and on-premise system becomes your next thought. So, again, to do that, you could start building your own code, and that's always an option. You could do that. Then again, you are spending time and energy into doing something which an infrastructure should provide. So what we have there is, we have this product I'll just talk about, which provides you a lot of templates. And there are, again, templates is, again, like patterns. So pre-made templates which tell you if you want to integrate Salesforce, this is how you do it. And a host of SaaS application. And this product particularly, it's called WebSphere Cast Iron. This has been one product where we have seen extremely small integration cycle, as less as 3 days. 3 days, couple of weeks is what it takes to have your on-premise system integrated with the cloud application. I mean, that's normally the time which with some big bang product, the install and setup takes. Cast Iron is an extremely intuitive offering. It is completely, configuration driven. The whole thing is we have just configuration, no coding approach. There are ways to define templates, and then you can create your newer templates. And it supports a whole range of a broad range of cloud and on-premise applications. You have ready-made connectors for on-premise applications like SAP.NET, Oracle, and so on, and templates for a host of cloud offerings like Salesforce, CRM on Demand, Amazon, all these cloud offerings. So this product lets you easily integrate your application which are inside the enterprise with the ones which are there on the cloud. Next big thing that we are going to look at is mobile. So, if you want to extend some services to the mobile device, again, it's your enterprise data which is eventually going to go there. So if a bank wants to offer a feature of notifying its customers if their account balance goes below the minimum balance. So I'm not talking of SMS alone here. I'm talking of notification framework for the smartphone. SMS is of course one way to do that. So the information to do that, to make that decision, has to come from the back end. And again, the whole set of integration challenges come up. You have a new channel, mobile. It has a different set of protocols it follows, different data format, like JSON is what we use to transmit data from mobile. And you have the enterprise, which is talking some different protocol, running on some different enterprise systems. So again, here we have the IBM Mobile Foundation, which is there, which is a set of product, I mean much more than just integration. But if you just talk of integration here, the whole IBM Mobile Foundation is a topic in its own. We could have a whole webinar on that as well. But you know, that is a range of things which let you develop mobile application, takes care of maintaining your code for different type of devices like Android versus iOS. You don't have to write again and again. So it's a different product. But what when we talk of integrating to mobile, what becomes important is you have some services which you want to expose on mobile. So for instance, you have a .NET service which you want to make available now on mobile. So again, Message Broker is the product we use there. What Message Broker can do, there are patterns again, as I told you, there are ready-made patterns. So there is a pattern which lets you mobile enable your .NET service. So all you have to do is select that pattern, fill in couple of things like which service you want to select, which is the method you want to select, and it gets available. When I say available, it generates the code which will do this for you, to do the transformation of JSON and JSON back to SOAP or whatever the service is using. So in as little as 2 clicks, you put mobile enable. If you don't want to give any configuration, just right-click the service and select mobile enable. It generates the whole set of code for you. And of course, it does it through IBM Mobile. I mean, when you eventually talk to the mobile, IBM Mobile Foundation helps you to do that conversation. After your mobile, of course, we saw cloud and mobile. So the third big wave is social. And I know I'm heading towards the top of the hour here, so I just try to do it quickly so that we have time for questions here. So when we say social, we are basically talking of APIs here. And I mean, for those of you, I'm sure all of you must be familiar with APIs. So Web API is a new space which is evolving now. There was a time when every company wanted to have a website. So if you do not have a website back in 1990s, you were missing on business which was coming through the web channel. And today that's kind of a given. If you don't have a website, you're definitely missing on a whole chunk of business which could come to you if you had a website. Similarly, Web API is another channel for an enterprise to interact with their end users or the end customers. So it's an example which I have on this chart. If you can see it, chart number 29. eBay, if you see, eBay does almost 7 billion worth of business through APIs. So which is like a huge amount. Similarly, Twitter, if you see, it draws 10 times more traffic than its website through APIs. So Amazon is another example, and so the list is full of examples. So when we say web APIs, if we oversimplify it, suppose there is a company and maybe an airline, okay? So to book tickets with an airline, one way is you go to the website of the airline and book it. Another way is that the airline exposes web APIs. What that means is, the moment you expose web API, any developer can develop applications using those web API. So those applications, I mean, the company doesn't own the application which is going to use its API. Anybody could use those APIs and create an application, like what you can do today with Twitter. Anyone can use Twitter APIs and create a new application today. So what that does is it opens up far more channels for people to reach you than you could have ever thought of. You could have your own mobile app, which is a different thing. API is a different domain here now. So if you want to go for web API kind of development, the product that we have, I'm on chart 30 now, is Cast Iron Live, which is available as a hosted solution right now. So there is a URL which I have at the end of the chart. It's webapi.castiron.com. If you go there, you could download a 90-day free trial version from there. I mean, when I say trial version, you can sign in and take a login ID, which entitles you for a trial license. What this product lets you do is it lets you create the web API without any coding. Again, this configuration. You can create an API. You can socialize that API with the developers, or you can popularize that API, and then finally you can see your dashboard in terms of, suppose you have exposed 10 APIs, which API is being used how much. That kind of a dashboard can be displayed. You could see the usage statistics. You could see the the uptime of your APIs and different things in the form of analytics. That is the social side of integration. How do you do that integration? And then when you are exposing web APIs, then definitely security becomes a concern, because you're opening up a function which anyone can call. So at that point, depending on what your requirements are, if you are opening up your enterprise for channels where you do not know the end user, like mobile or web API or any of the other sensors related channels, you kind of need to take care of your firewall, which can be, there's an offering that we have in that space, which is called WebSphere DataPower, which is an appliance which lets you kind of do this enforcement very simply. So you could sign, verify, encrypt, decrypt with zero coding. Anything. So it's an appliance which sits in the firewall, and all the calls that come into your enterprise go through DataPower. Again, a very popular offering from IBM, but then it depends on your use case. So if it's just, it depends on how many users you have, what is the throughput that you need. Because it's an appliance form factor, if your load is very less, it might not be very economical for you to go for a DataPower. If it's a huge enterprise where the number of hits expected are large, load is more, the parsing is, transformation, parsing, scalability, all that is going to come with this appliance. And then lastly, we talk of big data. So when we say big data, we are talking of connectivity to remote sensors, meters, and so many other endpoints which we never thought of. It's an explosion of data which is out there, right? So when we see connectivity in specific, there is a whole new area of analytics on big data, which is a big thing these days. But to do that analytics, you need that data together at a place. And when we say connectivity, what we are essentially talking about is how do you get the data from these remote, devices. Devices as in you could need the data from a moving train, for instance, or from a gas pipeline. All that can be done using sensors. So the offering which lets you do this kind of work is, I've already spoken about this MQ telemetry transport, MQTT. It lets you instrument different endpoints. It could be absolutely, and mobile is also one of them. MQTT is being used for mobile as well, along with, of course, HTTPS is there, but MQTT is another way of leveraging the mobile. So it lets you directly integrate to the device and get that data into your back office. And this protocol is extremely customized for a low bandwidth kind of a network. So if you have, for instance, the data which has to be sent from a sensor, you do not have the luxury of a high bandwidth. You have to send that in minimal bytes. If you start doing that on HTTP kind of a protocol, which is extremely verbose with a huge set of header details, you will spend or expend that bandwidth in just passing that data, which is not the real data. So MQTT takes care of packets as less as 2 bytes. And that's where the whole instrumentation of these devices can be done. They can be interconnected using the backbone that we talked about. And that is going to give you the intelligence in terms of the analytics capability, which is going to be only after you have the connectivity in place. So with that, I think I'm towards the end of my presentation. And quickly I'll touch upon, in the space of connectivity and integration, IBM is the #1 market leader. And what I have there on chart number 34 is a quote from the report which was published by Gartner. We have in messaging a large customer base of 25,000 plus customers. There are hundreds of success stories which are available on IBM.com. If you go to IBM.com/connectivity, you can go through those. There's a very strong ecosystem in terms of business partners and user groups that we have. And as I said initially, we have like over 15 years experience, hundreds of assets, and a very deep and a broad set of solution and portfolio. So with that, I would just open up for any questions that you may have. And just for a quick recap, we talked about the messaging backbone and the product that we have from IBM. The offering that we have is Message Queue. Then we create an ESB on top of that, which is through Message Broker. And then if you want to leverage the newer trends of mobile, cloud, big data, and social, that's the whole set of the different offerings, or not really the same offerings are leveraged there, but we have, like, for instance, cast iron specifically for cloud connectivity, DataPower for security. That kind of gives you a broad view of what the connectivity and integration portfolio of IBM looks like. So thank you, and if you have any questions, I'll be happy to take. Okay. I do see some questions here. One sec. Okay, so we have a question asked by Rajiv Srivastav. How IBM MQ is different from Oracle integration suite, okay, or web method, or any popular tools? Do we get anything extra features? Okay, so IBM MQ, I wouldn't say the products that you have mentioned would be more like ESB kind of a space rather than MQ really. We compare MB with them. So, I mean, MQ has been different in terms of just the industry confidence which we have had on this product. So I cannot think of anything comparable in Oracle, for instance, to MQ. So MQ is the the basic backbone that we use for transferring message. It is not the ESB. ESB is message broker from IBM. So I wouldn't really want to differentiate MQ against these products. But if you talk of ESB, I think the key difference, which is a question which I get asked very often, is, and kind of situation which we get into with when this kind of question is asked compared to Oracle or web method or anyone else. We at IBM, you would notice we sell products separately. Like we have a ESP, which is message broker. Then we have a process server, which is a different product. And if our customers need both, then we put up a deal which packages both and sells. Whereas for instance, Oracle Fusion. Oracle Fusion is a full platform which gives you everything. Now there are pluses and minuses. How we would want to view it is because we always have an option of taking everything that you want, but we don't want to. If a customer just needs connectivity, we do not want to burden them with BPM. So it's only the connectivity is the need. We would just want to give that piece and let them graduate to the next level where they need process automation. That is, I think, a major difference packaging-wise which I see. And when it comes to features, I mean, of course, there are a lot of connectivity points which we support. I wouldn't want to go into what Oracle really supports there, but definitely message broker. If you look at the Gartner is an analyst and a very reliable source. If you look at their Magic Quadrant that they publish, message broker is definitely it's way ahead. So which is a feature comparison that we normally follow. Okay. So there is a second question from Gauri Shankar Babu. Okay, the question is, you mentioned 25,000 customer base. I want to know 25,000 customer in which application, like Tivoli. No. Well, I'm only talking about connectivity customers here. I'm not talking about any other Tivoli is a different brand. I'm not even talking about our WebSphere applications server customers. I'm only talking about message queue, message broker, cast iron, DataPower, the products which I spoke about, the connectivity and integration product customer number is around that. Any other question anyone has? So, yeah, I mean, I just hope it was helpful, and it's a cross product, and the intent of this session was to give you an overview for all of them. If there's a particular interest in any one of them, we could obviously have a deep dive and a more focused discussion on that product. Thank you. Yeah, over to you.
Those were the only questions we had, Sargam.
Yeah, those were the only questions.
Thank you so much for the insightful presentation. I'm really thankful to you for conducting this webinar. The recording of the session would be available on techgeek.com by today evening by 6 o'clock. I guess we have one more question, Sargam. I'm sure you would love to take it.
I don't see anything, but these are the two which I see. What is the question? Can you repeat it?
How would it make a difference for the emerging developers to take into account the help of APIs?
Okay, yeah, I see it now. Around APIs, you could create completely different use cases. A very successful example which I can give you is we have these social networking platforms like Facebook, Twitter, LinkedIn, and so many others. What we are seeing as a trend, you have people who go and create Facebook applications. So recently I saw a Facebook application which aggregates YouTube features along with Facebook. So it shows you the friends who have birthdays coming up, and then it lets you go and record a video message, a video greeting for them, and post the link to your YouTube recording onto your Facebook page. So essentially what this application is doing is, this application is invoking the APIs from Facebook, from YouTube to do all this for you. This is a use case which Facebook or YouTube may not have thought of at all. It's that developer's imagination who thought that he could use these two things together and create a completely different application. Now when this application gets used, in turn there is traffic going to YouTube and there is traffic going to Facebook. And that's what it means, when we say that they are getting more traffic through APIs, then they're getting directly on their site. So developers can think of these, like you have a couple of applications. You have social aggregators which are available. In a single screen you could see your messages from LinkedIn, Twitter, Facebook, status that your update gets posted to all three of these. So those are some applications where developers are using these APIs and giving a new look or a new thought to the whole process. And similar things can happen. I'm talking of social media examples. Similar things can happen with enterprises as well. We are just seeing a trend where enterprises have started exposing APIs, and this is a big market. I hope that helps.
Yeah, thank you so much, Sargam. I'm also thankful to all our participants for making this webinar a success. Thank you all. Have a great evening.
Thank you.